Do you remember invisible or disappearing inks? The ones we usually used at school when we were young? You need to know that that magic was very difficult to produce. The developing of these inks is anything but simple. And in ceramics, of course, we do not use invisible inks, but the formulation of digital inks involved in the process is even more complex. Today, we will focus on this very important product category. It's going to be a very short episode, and in a few minutes, we will try to make a sketch listing the most important features that must be taken into consideration. I am Davide Trentini, and this is Apparently Invisible, Chemistry in Ceramics. Let's start by saying that in recent years, ceramic industry has evolved and grown a lot thanks to the digitalization of some important processes. And in this regard, the digital printing process surely plays one of the most important roles. What happened? It happened that the use of digital inks has almost completely replaced the old decoration system, incredibly widening the possibilities both on a technical and aesthetical level. And you need to know that the formulation of digital inks and therefore their production is very delicate and complex, since it must strictly comply with specific parameters. But the question is, of course, what kind of parameters, or what are the parameters that affect the features of digital inks? Let's try to make a list and to offer here a general overview about their most significant features. Well, first of all, a definition that might seem a little bit trivial, but that instead is important to remember as, I could say, a starting point. To better understand the features of an ink, in fact, it is important to define its composition. And here it is. All inks involved in the ceramic production process consist of a solid part dispersed in a liquid. That's clear, of course. More precisely, we could say that the solid part is made up of inorganic pigments. I repeat it, inorganic. The inorganic nature, in fact, is essential since it more easily withstands the very high temperatures of the ceramic firing cycle that within the kilns can reach 1100 or 1200 degrees Celsius. Why do I say that? Because organic pigments, instead of inorganic, would burn and disappear during the firing cycle, leaving no trace, that is, no color and no design. At present, two are the main categories of digital inks that can meet the need of producers. We are basically talking about solvent-based and water-based ink products. The most significant difference between the two is based on the different kind of solvent within which the pigment is in suspension. And in this regard, we can talk about non-polar solvent when we refer to solvent-based digital inks, and polar solvents in case of water-based products, because as we know, water is the most representative example of polar solvents. Even the composition of these two categories of ink shows an important difference. The formula and the composition of a solvent-based digital ink consists in 60-70% of non-polar solvents and chemicals and a 30-40% of pigments, while a water-based digital inks is made up of 30-40% of polar solvents and chemicals, 25-35% of pigments, and a 30-35% of water. It is also important to know that the chemical nature of the pigments, that is, the solid part, may change according to the color. Just to make an example, a blue ink contains cobalt aluminate, while the use of tin and chrome spheres allows you to reach more pinkish shades. In any case, to put it shortly, we are basically saying that the final color of the tile depends also on the materials involved. Let's see the liquid part now. The liquid part of the ink that, as we said, can be polar or non-polar, is usually developed by using chemical marked by a dispersant action. In this regard, the quantity of the chemical involved in the formula is a must, since they are responsible for the definition and adjustment of the main parameters of the ink. But what are these parameters? Particle grain size, viscosity, surface tension, drying times. Once we have agreed that these are the most significant ones, we can now address the grain size of the solid part, that is, of the pigments. Well, since we are addressing now the grain size, we need to know that the piezoelectric application system involves or implies the use of digital print heads provided with nozzles whose diameter is about 50 nanometers. This is the reason why pigments must be nano-size. More precisely, the particle dimension must be about 1 micron. Greater dimension, in fact, may promote agglomeration phenomena, blocking the print head and the production line, therefore negatively affecting the industrial productivity. We can also add that the grain size of pigments may affect the proper development of the color and promote unexpected sedimentation phenomena. In general, smaller sizes lead to a less color development and to a reduction of possible sedimentation. Let's see now the second of our main features, that is viscosity. We already know, but it is important and useful to remember that viscosity measures the attitude of a substance, that is usually a fluid, on generating friction between its layers. It basically defines the fluid resistant to flow, and in liquids, the coefficient of viscosity is inversely proportional to the temperature. The more the temperature increases, the more the viscosity decreases. From a microscopic and particle point of view, the value of viscosity depends on the shape and size of the molecules and on their kind of interaction, of course. Speaking of digital inks, viscosity values must range between very rigid parameters to properly develop the dimension of the drop of ink during discharge so as to avoid printing defects. At present, according to the general parameters of ceramic industry, the viscosity should range from 10 to 30 centipoise, that is the unit used to measure viscosity. So, from 10 to 30 centipoise, also considering the temperature of the ink during the discharging from the print heads to the ceramic supports. Good. Another important parameter is, as we said, the surface tension. That, as we already know, it is the tendency of liquid surfaces at rest to shrink into the minimum surface area possible, and that defines the cohesion force of the particles that are on the superficial part of the fluid. Even the surface tension is a fundamental value that can affect the proper formation of ink drops. Just to give you a general indication, the surface tension of a solvent-based digital ink should range between 28 and 35 Newton per square centimeter. That is a value that probably does not make sense to the most of us, but that instead, for a technician, is very clear and important. I just want to add that some producers are already developing digital printhead able to work with higher surface tension values. But I stop here with these issues, and I suggest you to listen to the previous episode that, by chance, is all about surface tension, just to give you a suggestion. That said, let's end our episode with a quick word about the ink's drying times. On this parameter, I just like to say only that since the scenarios are very heterogeneous because of the different production parameters that can range not only from company to company but also according to each production line, it is important to provide the ink with a drying time that can properly match the applications that precede and follow the discharge of the ink, in order to promote a correct stratification and reaction between the various application layers, that is, glue, grit, glaze, etc. To make this happen, it is clear that you need to take action with specific categories of chemicals. So, very shortly, both solvent or water-based digital inks are developed to get a proper balance between all the parameters, so to promote the best performance as possible. This is the reason why a previous study within the R&D lab is a mandatory to reach the desired target. And so, even today, with this brief mention to drying times, we have come to an end. As usual, I remind you that you can listen to the previous episodes on the main platform, such as Spotify or Apple Podcasts, or on our app, where you can find a lot of other contents and that you can download for free on Apple Store or Google Play. You just have to type Z&S Ceramco or Apparently Invisible. So, just like a disappearing ink, I disappear as well right now, but I will be back in a couple of weeks. See you soon.